two things to be found out regarding a vector: its magnitude and direction. So if you find a vector in the form of some xi plus yj plus zk, then its magnitude will be root of x square plus y square plus z square. Xi plus yj plus zk vector magnitude will be root of x square plus y square plus z square. Okay, then direction of a vector can be represented in terms of angle. So mostly we use tan theta. Tan theta is equal to y by x, where y is magnitude along y direction, magnitude along j direction, and x is magnitude along I direction. Okay.
Sir, I have a doubt from previous class.
Uh,
Sir, here exactly at this point, minus x square plus minus y square plus z minus z square. How does it become x square plus y square plus z square root, sir?
what is minus into minus?
Plus, sir.
Minus x square is minus x into minus x, which is how much?
X square.
Oh,
Okay, sir. So even if it is minus at the end, it should be x square plus y square plus z square only.
yes, you need not worry about negative sign while writing the magnitude, because negative magnitude is meaningless in physics.
Okay, sir.
Next, after understanding magnitude and direction of a vector, we will see addition of vectors. Addition of vectors. Vector addition can be done in two ways. One is by
Sir, that is addition, sir.
component method, and the second is graphical method. Component method and graphical method. Component method, first we'll see component method, simple, easy. In graphical method, you again have, we use the three laws. There are three laws in graphical method. One is triangle law of vector addition. Second is polygon law of vector addition. Third is parallelogram law of vector addition. So depending on the given situation, we can use any one of the methods, any one of the laws to add vectors graphically. We'll come to that later. First of all, let us see how vectors can be added by component method. See, the first point that you should note is, while handling vectors, you should be very careful about the direction of vectors. Vectors are not ordinary quantities. They have a specialty. They have direction. That is their specialty. That is their significance. So this direction should be kept in mind, whatever operation you do on vectors. You cannot ignore the direction while handling vectors. 10-meter east is different from 10-meter west. Both are 10-meter, but if you go 10-meter east, you will start from here and end somewhere here. If you go the same distance 10-meter west or north, you will end up somewhere here. So your destination is completely changing if you ignore the direction. So direction should always be kept in mind. Now, if you just take addition of scalar quantities, addition of scalars. You have been doing this right from your LKG or UKG. Okay, 1 plus 1 is 2, 2 plus 3 is 5, 10 plus 10 is 20, 11 plus 11 is 22, 3 plus 4 is 7. That 3 can be, that these 3, 4, 7 can be 3 meter and 4 meter, or it can be 3 meter per second, 3 meter and 4 meter displacements, or it can be 3 meter per second and 4 meter per second velocities, or it can be 3 Newton and 4 Newton forces. Okay, whatever quantities you, not this, other than vector quantities, whatever you add here, the result of 3 and plus 4 will always be 7. You don't find any exception while discussing or while handling scalar quantities. Whenever you add 3 and 4, you'll always get 7. 3 kg rice plus 4 kg rice will always give you 7 kg rice.
It's like in scalars or relation of scalars, sir, like the values should be
Ordinary
same,
numbers.
sir.
Scalars are just like ordinary numbers. You can perform
Okay,
all
sir.
your
In
algebraic
vectors, sir, it's
operations
like
on
it should be the same, sir, the values, sir.
uh,
In the same, like the, for example, sir, it should be Newton or Newton, meter or meter, like that.
even in scalars also it's the same thing. You cannot add 3 kg of rice to 4 liter of milk, right? It's meaningless.
Yes, sir.
We always add, subtract similar physical quantities.
Kg and grams, sir. Exactly.
Units might be different, but quantity must be same.
Yes, sir.
So 3 plus 4 always gives you 7 in scalars, but in vectors, in vectors, 3 plus 4 can give you 7. 3 plus 4 can give you 5. 3 plus 4 can give you 1. 3 plus 4 can give you 6. Different possibilities are there. How? Right. To understand this, first of all, uh, okay, if I take a simple, just a illustration, let us say this is some body of mass m, and on this body, a 10 Newton force. Newton is a unit of measuring force. That's how you measure distance in meters, time in second. Force is measured in a unit called Newton. A 10 Newton force is acting like this, and another 5 Newton force is acting like this. The resultant force acting on this is 15.
15 Newton.
If I change slightly, 10 Newton force is acting like this. 5 Newton force is acting like this. The resultant force now is 10 minus 5, which is 5 Newton. If 10 Newton force is acting like this and 5 Newton force is acting like this, then you get some different value of the resultant force, which you'll understand after we discuss parallelogram. It is neither 5 nor 10 nor 15. It's some value between 5 and 10. It's some value between 5 and 10. What are we doing in all these situations? We are adding the forces. We are adding the forces. As force is a vector quantity, you don't get always 10 plus 5, 15. In this case, it is 10 plus 5, 15. Okay. But here, even though you are adding the forces, but we are doing subtraction here because this 5 Newton is acting in the opposite direction. As direction has significance, 10 Newton towards right and 5 Newton towards left these are not same as this situation. As the directions were same here, we can just add them 10 plus 5, 15. But here directions are opposite. So you should take the difference. Here directions are perpendicular. You have some other method to apply there. We will come it later. If the angle is something else, like instead of 90 degree, it is 30 degree, 40 degree, 60 degree, some angle between the two forces, then you apply some other rule and find out the result. Like that, the result of or the sum of 10 and 5 is not always 15 in vectors. Okay. Right. Now, if we try to understand how we add vectors by component method, addition of vectors by component method. Simple method, component method of vector addition. Suppose I have two vectors, vector P, which is given as Pxi plus Pyj plus Pzk. Pxi plus Pyj plus Pzk. Immediately you should understand that the value of this vector P along I direction is Px, value of this vector P along J direction is Py, along K direction is Pz. As I direction is X direction, I am using Px here, suffix. J direction is Y direction, I am using Py. K direction is Z direction, I am using Pz. This is one vector P. And the second vector Q, Qxi plus Qyj plus Qzk. So value of vector Q along I direction is Qx, along Y direction is Qy, along K direction is Qz. Okay. Now I want to add these two vectors. Vector P plus vector Q will be Px plus Qxi plus Py plus Qyj plus Pz
PZQZ.
plus Qz. Okay. What are we doing here? We are adding the components of each vector which are in the same direction. Px and Qx are in the same direction I. Py, that's why I'm adding them. Py and Qy are in the same direction. J, that's why we are adding them. Pz and Qz are in the same direction. K, that's why we are adding. So in vectors, you can add those vectors directly, just like scalars, which are in the same direction, like this. 10 and 5 are in the same direction. So its sum will be 15.
Sir, it is
If
just like A bar cross B bar, no, sir?
A bar cross B bar is a different thing. What A bar B cross B bar are you saying, which you got in mathematics or what?
Physics only, sir.
A bar cross B bar.
Dot product. Dot product and cross product.
We have not come to that. We have not come to that yet. Slightly different. It's different. In dot product, you don't get IJKs. Here there will be IJKs.
Yes, sir.
So if you find two vectors in the same direction, then you can simply add them like scalar quantities. 10 Newton, 5 Newton, same direction. Sum is 15. 10 Newton, 5 Newton, opposite directions, you cannot add them normally. 10 Newton, 5 Newton, different directions, you cannot add them normally. Only when two vectors are in same direction, you can add them like scalar quantities. Okay. As Px, Qx are in same direction, we can add them. Py, Qy are in same direction, you can add them. Pz, Qz are in same direction, you can add them. You cannot add Px and Py like this. Sorry, Px and Qy like this. This is wrong. This is not possible because Px is along its direction. qy is along y direction. Directions are different, you cannot add them directly. So point to be noted, vectors can be added directly only when they are in same direction. If they are in different directions, what to do? There is a procedure, we will come to that. But when you add vectors by component method, you need not worry about the direction. When you are adding vectors by component method, you need not worry about the direction because ijk's are there to tell the direction. So simply add I to I, j to j, k to k. That's all. You will get the resultant sum of two vectors. We have a vector p is equal to 2i minus j plus 3k, and vector q is I plus 2j. Okay, I will take all pluses first, plus 3k. Then the sum of these two vectors, p vector plus q vector, will be
3i plus
plus
3
3i plus 3jk plus
j
3
plus 2j,
6k
3k plus 3k.
6k.
6k.
That's all. Simple. If vector p is
Like
the
algebra, sir.
and vector q is minus I plus 2j plus 5k, then
Sir,
p
minus I, sorry, plus I plus j
I will write it like
and
this: 2 minus 1i plus minus 1 plus 2j plus minus 4 plus 5k. I
I
am
plus j.
writing the coefficients only. I am writing the coefficients. So this will be 2 minus 1 is minus I. 2 minus 1 is minus 1. Sorry, 2 minus 1 is plus.
Plus one, sir.
So this is 1i, or
I
you can simply write it like I. Minus
j.
1 plus 2 is again plus 1. Minus 4 plus 5 is again plus 1. I plus j plus k. Vector p is minus I plus 2j plus 3k. Vector q is 2i minus 2j plus 2k.
Sir,
P plus
I
q is
plus j.
minus 1 plus 2i plus 2 minus 2j plus 3 plus 2k.
Sir, we can directly cancel plus 2j and minus 2j, no, sir?
Yes. I 2 minus 2 is
I plus
0
5k.
plus 5k. As there is no magnitude along j direction, we don't write it. So P plus Q is I plus 5k. I plus 5k. Simple. There is nothing new here. The only thing that you should keep in mind is you should add only I to I, j to j, k to k. Then we cannot add I to j or j to k or k to I. That's all. In the same way, if you take subtraction of vectors by component method, subtraction of vectors by component method. We follow the same procedure, similar procedure. The only difference is instead of addition, it is subtraction. That's all. If vector P is given as Pxi plus Pyj plus Pzk, and vector Q is given as Qxi plus Qyj plus Qzk, then vector P minus vector Q is equal to Px minus Qx I plus Py minus Qy j Pz minus Qz k. So simply subtract I from I, j from j, k from k. That's all.
Sir,
Hmm.
once can you scroll up? Yes, sir. Here we took IJK both, no, sir. If there is no I, sir, what we can do, sir?
There will be only j and k.
No, sir. Like if it is 2j plus 3k and q is equal to 2i minus 2j plus 2k. I plus 5j plus k. 3k.
That's all.
Sir, that means why did we take 0, sir?
Because in Q, vector Q, there is no I value. That's why I wrote 0.
Okay, sir.
So here you should do just a subtraction. That's all. Instead of addition, you apply the operation of subtraction. Same procedure. Vector P is 2i plus j minus 3k, and vector Q is I minus j plus k. If I do vector P minus vector Q, which will
I
be 2 minus 1 I plus 1 minus of minus 1 j plus minus 3 minus 1 k.
I
Sir,
plus
I plus 2j
minus
minus
4.
4k.
I hope everyone knows rules of subtraction. So nothing new here, nothing complicated.
Sir, minus 4i minus 4j minus 4k.
Sir, your voice is not coming.
Yes. P vector P is minus 4i plus 3j minus 4i plus 3j. Vector Q is 2i plus 4k. P minus Q, vector P minus vector Q. Minus 4 minus 2i plus 3 minus 0j plus 0 minus 4k minus 6i plus 3j minus 4k. So this is how you perform addition of vectors by component method. Addition of vectors by component method. Only thing to be kept in mind is while adding I to I, j to j, k to k. While subtracting I from I, j from j, k from k. That's all. Next, if you go to the second method of addition, which is graphical method. Graphical method. In this, we have three laws: triangle law, polygon law, and parallelogram law. Okay. So
Sir,
first of all, let us see triangle law of vector addition.
sir, those are types of addition only, sir. Means multiplication, subtraction, they are
Three
different.
methods are there. There are no separate rules for subtraction in vectors. We subtract vectors just
Okay,
by
sir. So
reversing their
addition
direction.
means addition and subtraction. Multiplication and division
Hmm.
different, sir. Okay, sir.
They are different. Addition of vectors by graphical method. First is by triangle law. Triangle. What does this triangle law say? First point is these laws are used to add vectors. These laws are used to add vectors. If a vector is represented by is represented graphically, we represent vectors graphically by arrows. Suppose I want to add, this is 3-meter displacement and this is 4-meter displacement. The resultant of these two will be 7-meter displacement. Okay, as they are in the same direction, we don't have any problem. You can simply add them. If vectors are in same direction, you can directly add them without thinking much, without bothering about the direction. Only when they are in same direction. But when they are in different directions, then you should think. So this 3-meter, 4-meter added gives you 7-meter. Okay. But if this is 3-meter and this is 4-meter, you cannot say that it is 7-meter. 3-meter is in a different direction. 4-meter is in a different direction. In such situations, we can apply triangle law. So what does this triangle law say is, if two vectors are represented by two sides of a triangle taken in order, then their resultant is another name for sum or addition or net. We call it as resultant here in vectors. Result of two vectors. Then the resultant is given by the closing side of the triangle taken in reverse order. Taken in reverse order. If you understand this line by line, two vectors are represented by two sides of a triangle taken in order. I want to add two vectors. How are these two? Now, vectors are not given in component form here. They are not given in IJK form. One vector is given like this. Let us say this is some vector A represented by a arrow. What is its magnitude? All these things later. Try to understand conceptually how we are adding vectors by a triangle. What will be the numerical value? We'll come to that later. Understand the method here. That's important. If two vectors are represented by two sides of a triangle, vector A is one vector. Vector A is one vector. And vector B is another vector, like this. This is vector B. It can be in any direction. I'm taking like this. Taken in order. If two vectors are represented by two sides of a triangle taken in order. Taken in order means in order. This order is very important in triangle. Order means, see, simple. I can draw a triangle like this. Start from A, go to B, from B, go to C, from C, come to A. So my order is A to B, B to C, C to A. This is one order. Or I can draw it in the exact reverse order also. I can start from B, go to A, or I can start from A, go to C, from there go to B, from there go to A. This is reverse order. You can call this as clockwise, this as anti-clockwise. So you can draw a triangle in any one order, clockwise or anti-clockwise. Okay. So here I am taking the two sides, two vectors, A and B, as two sides of a triangle in one order. What is that order? A to B, B to here. This is one order that I am following. Okay. Then the resultant is given by, resultant means sum. Resultant means sum of two vectors. Then the resultant is given by closing side of the triangle taken in reverse order. Closing side of the triangle. Triangle has three sides. We have already two sides here. So the closing side is this. Closing side is this. Taken in reverse order. This is very important. So what should be the direction of this third side of the triangle? You can have this either in this direction or in this direction. But here it should be taken in reverse order. You have followed one order while showing A and B. This and this. And if you go in the same order, it will be this. But we should go in the reverse order. Therefore, it will be this. This is the resultant of A and B. C. That means if you add two vectors A and B, which are like this, the resultant of these two will be a vector C, which is like this. How much will it be? What will be its value? What is its direction? Later. Understand the concept.
Sir, it is also same like Pythagoras theorem.
Magnitude is same, but direction is, it depends on direction.
Okay, sir.
So if I take a example, a man walks 4 meter towards east and 3 meter towards north. Four-meter towards east and 3 meter towards north. Then what is his distance and displacement from initial point, from starting point? From starting point.
Sir, what is displacement?
Listen first. If you listen to me completely, you will not get that. That's what I have been telling to you. If you listen to me completely for 5-10 minutes, whatever common doubts you get, they will be clarified during my explanation. You, before I tell the thing, you ask that. That's the point. So a man is walking, let us say he's starting from here. He is walking 4 meter towards east. This is east. Okay. Then he turns towards north and walks 4 meter towards north. Sorry, 3 meter towards north. This is north. Now, what is his distance and displacement from the starting point? I hope everyone knows what is distance. Distance is the actual path traveled. Distance is the actual path traveled. So distance is simply 4 meter plus 3 meter. Because distance is a scalar quantity, you need not worry about the directions. So it is 4 meter plus 3 meter, which is 7 meter. Okay, fine. What about displacement? Displacement might be a new term for some of you. Displacement in simple, it means shortest path. Shortest path between initial and final positions. What is his initial position? He started from here. Let us say A. What is his final position? He stopped
and
here.
5 meters, sir.
So displacement is shortest path between initial and final positions. Initial position is A, final position is B. Shortest path between A and B
5
will
meters.
always be a straight line. Shortest path between A and B will always be a straight line, which is this. So now this is his displacement. This is not distance. This is not the shortest path. This is not the shortest path. This is not the shortest path. Only straight line is the shortest path. You call that shortest path as displacement
Say
between 2 points.
displacement spelling wrong.
So shortest path between initial and final positions is displacement. And by this is, okay, if I apply Pythagoras theorem here, I can write this displacement as Pythagoras theorem. Displacement is the
We say
potential of the,
that
so it is 4 square plus 3 square, which is 16 plus 9,
25 room.
which is 25, which is 5 meter. So even though his distance covered is 7 meter, its displacement is only 5 meter. And what is the direction of this displacement? Direction of this displacement, it is from A to B. A to B. So it is this A to B. And this is what is triangle law. This is what triangle law says. Here I am representing a displacement of 4 meter by one vector, displacement of 3 meter by another vector, which are two sides of a triangle. Then their resultant is given by the third side of the, or the closing side of the triangle, taken in reverse order. This is the closing side of the triangle. This is the displacement, resultant of 4 meter and 3 meter. So this is what is triangle law of vector addition and how you apply it.
Sir, what
Sir,
is
how
the difference for distance and displacement, sir?
First of all, you tell me what is distance.
Sir, shortest part.
Displacement is shortest path. That's what I have told you.
Distance, sir. The
Path
total path is covered by the
is
length.
distance.
So the actual
You
length
start,
covered.
you start from your home. Your school is here. But the path that you go, the road is something like this. You first of all start from your home like this, and you take a right turn. Then again you take another right turn. Then you go straight. This is the distance. Actual path from your home to school is the distance. But
Yes,
the
sir.
displacement from your home to school is this. Shortest path between 2 points is displacement.
Okay, sir. Understood, sir.
Sir, how can we say that triangle AB is a right angle triangle?
What will be angle between east and north directions?
Sir?
What will be the angle between east and north directions?
90, sir.
Oh.
The perpendicular, right?
Okay. So this is triangle law. To add two vectors graphically, we can make use of triangle law. You
Yes,
should
sir.
remember the statement, and that order is very important. The closing side of the triangle must be taken in reverse order. Otherwise, you will get it wrong.
Okay, sir.
Okay, sir.
Sir, this is like the Pythagoras theorem only, no, sir?
Only when the two vectors are perpendicular. They need not always be perpendicular.
Sir, displacement
Okay, sir.
direction also we have to write now, sir. 5 meters.
Yes.
Sir, you only wrote 5 meters now, sir.
Yes, I wrote 5 meter. That's what I told. Just try to understand this conceptually first. Then later, when we do questions, when we do exercises, you'll get all the details.
Okay, sir.
Print అది మీకు రెండు
Okay.
Sir,
Right.
I have
So
a
that's all.
doubt then.
We'll continue tomorrow.
Now, what you told is only when two vectors are there, sir.
Yes. You can apply triangle law only
Okay,
for two
sir.
vectors.
It is different, sir, for 3.
If there are more than two vectors, you should repeat triangle law.
That's it, sir. Sometimes they may, even if they may not be straight.
Yes. Your answer to this doubt, you would have got it in tomorrow's class if you listen to the explanation of polygon law.
Okay, sir.
Sir, what if
That's why you.
what if the two vectors are not perpendicular?
Then also you apply the same law, but resultant, finding the resultant will be a different procedure. If 3 meter is like this and 4 meter is like this, still the resultant is this.
Yes, sir. How do
Its
we
magnitude will be different. Its magnitude is different. Its direction will be different. How you find that? That's what I told you. Understand the concept first, why, how we are applying. You will get all these details in the coming classes. If I cover all the things only at once, most of you will not understand. That's
Yes,
why I'm
sir.
going step by step.
Sir, 3 polygon law, which will be covered in next class, sir. But sir, one doubt, sir. Will the line be straight, sir? Then
Which line is straight?
3 or more vectors.
You need not apply any law. You can simply add them. That's what
Displacement, sir.
Yeah, that's what I told. If you find vectors in same direction, you can simply add them like ordinary numbers.
Different direction, sir. I meant.
Different directions, you should go for either triangle or polygon.
Okay, sir. It being straight is not necessary.
Hmm.
Okay, sir.
Okay, we'll continue tomorrow.
Thank you, sir. Bye, sir.
Fine, sir.